So let's do another ANOVA problem, of course, a one-way ANOVA. So groups of men from 3 different areas of the country are being tested for their mean weight. The entries in this table are the weights from the different groups. At the 0.5% level of significance, are the mean weights similar throughout the country? All right. First question is, how many groups of men are we looking at? So it shows here we have group 1, group 2, group 3. So we have 3 groups of men. Why is that important? It's important because what an ANOVA does is it takes different groups and compares their averages together. So for group 1, we have their mean weights, and another way to say that is average weights. For group 2, we have their mean weights, and group 3, they have their mean weights. So what I'm going to do is they're going to average all these together by group and compare them. So is this qualitative or quantitative data? Right. This in the table is quantitative data because it's weights. Quantitative data. And it is separated by qualitative. But look in the groups, if the actual data you see is quantitative. So what is the null hypothesis? The null hypothesis is that the mean weights are similar throughout the country. Okay, and I just got that from the problem, and I'm going to put it that way. Okay, what's the alternative? I'm just going to put it right here. The alternative is that the mean weights are not similar throughout the country. All right. So now I am ready to put my data in Minitab because the next thing it asks for me is the F value and the p-value. Let me get this here and put this up here just so we know where they're together. Okay. So again, I got to get the F value, the p-value, and then from there I can answer my questions. So if I go to my Minitab, I already have my groups in there. I just copied and pasted them in. I'm going to go to Stats, ANOVA, one way. So since each of mine are in separate columns, I'm going to do, I put this arrow down and said response data are in separate columns for each factor level. So then I go click on group 1, group 2, group 3. All right, so then my options, again, keep it as two-sided, check the assume equal variances, and then put 95 because my significance level was 0.05. Hit OK, hit OK, and it gave me some stuff. So let's see. Again, it gives me what the null and the alternative should be. So that's a really good way to check yourself. It gives you the factor levels. So factor, again, is a way to say categories in an ANOVA. So factor levels were 3. Group 1, Group 2, Group 3. So if I keep going down, it gives me what I need. So I'm going to copy this. And I'm going to put it back in my problem. So I'm going to put it here. Okay. So my F value is, 3.74 because it's right here in this picture. My P value is 0.055. Okay. So my P value based on my level of significance, 0.055 is greater than 0.05. And again, if you're having a hard time seeing this, just add another 0 to make the decimal places equal. So because 0.055 is greater than 0.050, I'm going to do fail to reject the null. Okay, so what's my proper conclusion? So if I fail to reject my null, that means this is true and this is false. So at the 5% level of significance, the mean weights are similar throughout the country. Okay, so what does that mean when I go look at my data? It means that group 1's mean mean weight, group 2 and group 3 are very similar, so I can't say there's any difference in them because they're very similar.